Hello, today we are going to be covering 5.4, dividing polynomials. You guys will be able to divide polynomials using long division and synthetic division. So using polynomial long division, this is very similar to normal long division. Maybe we should go ahead and do a quick review of normal long division. Say we have the number 524 divided by 3. We first decide how many times 3 goes into 5. That is just once. Multiply 1 times 3, bring that down, and then subtract from there. And then bring down the next piece. Oops. Then we decide how many times 3 goes into 22. That is 7 times. Multiply 7 times 3 and bring that down. And that leaves us with 1, and bring 4 down to have how many times 3 goes into 14. That is 4 times. So we would have remainder 2 here, with the answer being 174. Now polynomial long division works very similar to this. Now we just have some x's and a quotient that is x plus 5. So we are going to write it out as if it was normal long division here. 4x squared plus 23x minus 16 divided by x plus 5. And we treat it like a normal long division. I am going to put a little work area over here, though, to help me out in deciding what I need to put up top for my answer. So what I want to do is I want to figure out what or how many and what number we need to multiply x by to equal that to 4x squared. Or an easier way of thinking of this is 4x squared divided by our x term. It's just this divided by our first term here. This is actually just equal to 4x when we simplify it down. So I know whatever I get here goes on top, gives me 4x. Then I multiply 4x down to both of these terms, and each of them goes under their respective terms down here. So the way we set it up is that this always has to be the same. These two must be the same. 4x times x gives me 4x squared. Those are the same. And then 4x times 5 is equal to 20x. Now I must then subtract. Basically, I take the opposite sign of all my parts here. So my opposite side would switch these both to negative. These two cancel out. And then I have 23x minus 20, which just leaves me 3x, and I bring down my next piece. Now this is the new thing I'm working with. I need to find out what 3x divided by x is now. That is simply 3. So I put plus 3 here. And then I multiply the 3 down, so 3 times x is 3x, and 3 times 5 is 15. I switch my signs on my two new terms. 3x cancels out exactly how we wanted it to, and we are left with a remainder of negative 31. So we have remainder negative 31. Here, do it this way. Remainder negative 31. So we have this guy here. Now you could also write the equivalent to this guy. Instead of writing negative 31 as the remainder, you would say 4x plus 3 minus 31 over x plus 5. Those are equivalent. So you take your remainder and put it over your divisor. Okay, so these two in blue are actually equivalent. Let us try another one. I'll have my work area over to the side once again. And then there's one thing I do want to point out that's a little different here. when we are dividing polynomials like this, we need to make sure to account for every degree that is smaller than the largest degree that we have. So we have a fourth, we have a second, we have a fourth, we have a third, we have a second. We need to have just an x and then a number. So when that is not included, we have to add that in there. So we need 3x to the fourth minus 4x cubed plus 12x squared plus 0x, because that's just a stand-in term, but he needs to be there for this to work, plus 5. Same thing with our divisor. It also has to have all the terms, so we need x squared plus 0x plus 1. We can't leave out an important term. So I gotta include that plus 1. And now I can go ahead and start dividing this out. See what 3x to the fourth divided by x squared is. That leaves me with 3x squared, so that goes up top. Then I multiply 3x squared down to every term. So 3x squared times x squared is 3x to the fourth, just what we wanted it to be. 3x squared times 0x is 0x cubed. That's our stand-in term. And then 3x squared plus 1 is plus 3x squared. We do need to change the signs on all three of these. So that way we can go ahead and subtract. The first set cancels out. That's what we needed to happen. And go ahead and bring down the rest. And then bring down one more term. From here, we take negative 4x cubed divided by our x squared. We are left with negative 4x. So that goes up top. And then we multiply negative 4x through. So we get negative 4x cubed plus 0x squared minus 4x. Change our signs. Cancels out. We are left with 9x squared plus 4x. Bring down the plus 5. And we are ready to go. Once again, 9x squared divided by x squared leaves us with simply 9. So we put a plus 9 up top. Multiply the 9 through to each term over on the side, and we have 9x squared plus 0x plus 9. Switch our signs. Cancels out. We end up having 4x minus 4. Now, we can't actually go any further than this. Once we have a smaller degree here than we have in our divisor, that is the end of the line. We have our remainder. Didn't get down to just a number, unfortunately. But here's our remainder. And here's what we had pulled out of that divisor with this remainder. Okay? So there are some cool things that we can get from this, such as if there is no remainder, we can write it as the factors. It's another way that we can factor. So let's see if this one we can do that. We're going to do polynomial long division again. Make sure that the degrees go from greatest to least and include all of them. So we are going to have to add some. X to the fourth plus 0x cubed minus x squared plus 0x minus 2 is divided by x squared plus 0x minus 2. And we start again in our work area. So we have x to the 4th divided by x squared. That just leaves x squared. Multiply it down through all the terms. And we can actually go ahead and get rid of the first two terms because they both cancel out. That doesn't always happen, but it happened to happen that way this time. And then we might as well bring down the next two terms from there. So positive 1x squared plus 0x minus 2, because we bring these both down. We go ahead and divide x squared by x squared. That is actually equal to 1. So we go ahead and put a 1 up here. Positive 1, multiply 1 through. That basically just means we bring everything down from over there. And we end up having to switch all the signs. And then, cool thing here, they all cancel out. So we have a remainder of 0 here. This means that this is a factor of this polynomial and that this is a factor of this polynomial. So we can write it in our parentheses, x squared minus 2 times x squared plus 1. If you wanted to, you could check by foiling to make sure we get back to the original. We do actually get back to the original, so that's pretty nifty. And these are our factors of the polynomial p of x. Okay? Now there is another way we can do this. It's called synthetic division. It might be slightly simpler just because you don't have to include all the x squared, x cubes. You don't have to actually think about those things. It just kind of works out for you. When using synthetic division, I'm going to set it up similarly right this second. Just bringing down our equation and bringing our possible factor over. Now when we set up synthetic division, we just separate the numbers that are out front of their letters from in them. So we pull out a 1, we pull out a negative 14, a 51, and a negative 54. We also solve this guy for 0, and we use the solution version. So our synthetic is actually going to be set up as 1, negative 14, 51, and negative 54, with a negative 2 and a little box out front. And then put a line under him. Okay? So we take the information from our polynomial as well as the x plus 2, and we set up our synthetic division. Once it is set up, let me move it real quick. The process is pretty simple. You bring down this first number, and then you multiply down here by this term, and then move it up here. So let's just try it. Watch where everything goes. So I take negative 2 multiplied by 1. That gets us negative 2. I put it up here between my line and my negative 14. From here, I add down. So I get negative 16. And then I repeat the process over. So I take negative 2 times negative 16. And I get positive 32. And then I add down and get 83. And then I take negative 2 times 83. I multiplied those and I put it up here. I get 166. And then I add down and get negative 220. Now, my number furthest to the right down here, this is actually my remainder number. So I know that my remainder is negative 220. So I can write that over here. Remainder is negative 220. And then moving to the left, this one is my constant term. This one is my x term. and this one is my x squared term. So I put the corresponding number in front of that variable, so 1x squared minus 16x plus 83 is my solution. Okay? With a remainder of negative 220. Now, something pretty cool here. If on Math Excel, it gave you this polynomial and asked you to plug in negative 2. So to find the solution when x is equal to negative 2. Well, when you do synthetic division with negative 2 out front, the remainder is actually going to be the solution if you were to plug in negative 2 for all these x values. So instead of doing all the work of plugging it in and solving and figuring that out, you can just do synthetic division, and whatever the remainder is, that is your solution. So that's a pretty cool thing. Just as a side note, do synthetic division versus plugging in the value. Okay? And then we can use synthetic division once again. This also needs to make sure that we take into account that there is no x squared here, so we'll put a 0. So I have 1 and 0 and negative 57 and 56. And remember, I need to do the solution to this out front. So it is positive 7, or basically the opposite sign. So I'm going to draw a line down here and bring down my first term. Then I take 7 times 1 and get 7. I add 0 plus 7 and bring that down. Then I take 7 times 7 and get 49. I can now add those down and get negative 8. 7 times negative 8 is negative 56. So my remainder is 0. That means 7 minus x is actually a factor of this. And I can go ahead, this will be my number term, this will be my x term, and this is my x squared term. I can go ahead and write that out, x squared plus 7x minus 8. And then if we want to put this in factored form, we go ahead and put the x minus 7 out. If you were to factor this out, you would get this as your solution. There's one more thing I want to do though. This guy is not completely factored. We need factors of 8 that subtract to 7. These two can. So I'm going to completely factor this. That way if I wanted to solve for the zeros, it'd be really easy to. Or if I just want the completely factored form, it is right there. Alrighty, that's all I have for you today. Go ahead and work on Math Excel.